Hydrolox has an impressive and long history in spaceflight, but now the fuel of choice is Methalox. So at this point you might say, why would you even consider using hydrogen? It's got so many downsides. Its boiling point, its density, its low thrust. Let's take each one of them. Yes, the boiling point is low. However, there have been many missions using Hydrolox into space, and there's been a lot of work on extending its use long enough for a moon mission. This includes active and passive cooling systems such as cryocoolers and external louvers. Low density, it does mean that your tanks will have to be bigger. This is a big penalty using stainless steel, but using aluminium, it's not such a penalty. Low thrust is massively important and makes using it for a first stage is really difficult. Second stage is somewhat difficult, but once you've got into orbit, there are no effective gravity losses and there is no problem with the thrust. Now, what about the upside? Well, before we move on to that, if you enjoy that, please hit the like button or enjoy similar content, the subscribe button. Now, what about the upsides? First of all, it's got a much higher ISP. Secondly, it has an easier route to sustainability of green hydrogen compared with biomethane. And finally, you could argue it's actually easier than methane for in-situ fuel production. Once orbital velocity has been reached, the low thrust but highly efficient Hydrolox fuel systems are king. Why? Because instead of using the energy or a component of its thrust to maintain its orbital height, all the energy now, its thrust goes to increasing its delta V.